Welcome to ARC's Supernova 2023. Tonight's 4 roundtable discussions feature our outstanding scholars in interactive conversations with distinguished moderators. While these scholars are not necessarily experts on these roundtable subjects, they come from a variety of scientific fields, and each one has conducted thoughtful research on these topics in preparation for tonight. Following the discussion, there will be time for Q&A. After the roundtable, please visit the scholars' posters, which are displayed all around the University Club. These posters are a fascinating sketch of each scholar's field of study. Now, thank you for joining us at the ARC's Roundtable on Climate Sustainability, Social and Philosophical Issues. Please welcome our moderator, Greg Dalton, founder, Climate One, and host, Climate One, the Commonwealth Club. And our scholar panelists, Lainey Casella, Biomedical Engineering, UC Davis. Joey Murphy, Astronomy, Astrophysics, UC Santa Cruz. Rochelle Stark, Metabolic Biology, UC Berkeley. And Alauna Wheeler, Physics, UC Merced.
Welcome, everyone. Thank you for joining us for this all-star panel. I'm Greg Dalton, host of the Climate One radio show and podcast based at the Commonwealth Club. I'm delighted to be here with these young scholars. Before we begin, I want to hear from you one word. What's something you'd like to hear about? You can just shout it out. I'll repeat it. So right now, what's one word that you'd like to hear on this panel today? Climate. Climate?
More species than the human.
More species than human. Hope. Trade-offs?
Good news.
Good news, hope, trade-off, species, climate, sorry? Solutions? Action? Okay, all right. Coral. Okay, there's a lot there. Thank you for that. So we'll try to note all of those. I'm not sure we don't have a coral expert up here on the panel, but coral is food for a lot of things. It's, bottom of the food chain. We'll definitely touch on food. So, all right, we're going to have each of our guests, scholars here, introduce themselves briefly, what they're doing, and what their area of research and expertise, and then we're going to have a conversation and include your questions. Let's start with Lainey. Welcome.
Hello. Thank you for having me. My name is Lainey Casella, and I'm a PhD student at UC Davis, and I study biomedical engineering. My research is mostly focused on developing electrically conductive biomaterials, so materials that can go into the body, to help heal wounds that otherwise don't heal themselves. And if you're wondering what that has to do with climate change and sustainability, I'm here to confess it has no relation. But I think that's a common theme with my fellow panelists, so I'm not up here alone. But I do find sustainability very fascinating. I would consider it one of my primary personal interests and hobbies. It's definitely what I use Google for the most after what I'm done doing research for my work. And so my role, sort of, on this panel is to talk about the impact of science on climate change and sustainability. I think a lot of us sort of operate with this idea that continuing to innovate scientifically is the answer to solving the climate crisis, but I think there are others, Greg maybe, might push back on that a little bit, because if we think about it, the Earth has been evolving through many different climates over the course of millions of years, and that demonstrates its ability to withstand the test of time and to adapt far beyond our wildest capabilities. So is science really helping? Is it kind of getting in the way? Definitely something that we're going to be discussing during this panel. I'm going to throw out sort of 2 ideas of some of my primary interests. So the first, kind of on the subject of is science helping or harming, I think that there is some middle ground in fields like biomimicry, which seek to mimic very specific examples in nature to make certain processes and technologies more efficient. So, and have a positive impact on the planet. So for those who might not be as familiar with biomimicry, one example is designing turbines to have ridged structures that mimic sort of the tubercles on humpback whale fins, and that makes them more efficient and apparently quieter. So positives there. The other area that I'm interested in, which is a little bit closer to my area of expertise, is thinking about the potentially negative outcomes of innovation, even if they're not, even if they are considered, perhaps they're not advertised. So for example, again, I study biomedical engineering, so I think about things in medical terms. And speaking very, very generally, the primary outcomes of medical research are to extend life or improve the quality of life. But we don't really think about potential ramifications of that. There is mounting evidence that as our population grows, the population contributes to greenhouse gas emissions. So as we are potentially extending life, like what effect does that have on the planet? So I'm not trying to stir the pot here. I know we all want to live longer. We all want our loved ones to live longer. We want to have families. We want to have children. So this is one of the reasons why I still hold out hope that we can use science maybe in ways that are more like biomimicry, so that we do not need to completely uproot the way we live without having such a big impact on the planet.
Thank you. All right, let's stir the pot. Okay, Rochelle.
Hi, I'm Rochelle Stark. I'm a second-year PhD student at UC Berkeley, and I'm studying in the Nutritional Sciences Department, metabolic biology. So I'm coming from this definitely more of like a food aspect, and I study a lot of classes, teach a lot of classes as a teaching assistant about nutrition, how food impacts people, but also how it impacts the environment, how it impacts our politics. So I am definitely coming at it from a food way, but I also want to talk about today, or I'm happy to talk about like how food affects your carbon footprint, little things we can do to change how our diet can affect the environment. But I'm also really interested in plant-based alternative development. So you might have heard of things like lab-grown meat or just general fake meats, stuff like that I think are really interesting. So that's where I'm coming from, and happy to answer any questions from the food sphere.
We'll definitely get into that. Yeah. Let's go to Joey.
Yeah, hi everyone. I'm Joey Murphy. I'm a fourth-year PhD student at UC Santa Cruz in the Department of Astronomy and Astrophysics, where I work with Dr. Natalie Battaglia. In my work, I use ground and space-based telescopes to detect and precisely characterize exoplanets, which are planets orbiting stars other than our sun. And by measuring the fundamental physical properties of these planets, we can dig up some clues about the physical processes that govern planet formation and evolution in the Milky Way. So as you might be following along in the news, it's an exciting time to be an observational astronomer in exoplanets. JWST is shedding light on a brand new era of exoplanet characterization, taking the most exquisite detailed spectra of exoplanet atmospheres. So these observations may potentially hold the key for us to discover life beyond Earth. So those are some of my research interests. But I also want to give just a little bit of personal background to kind of contextualize why I'm up here talking about Earth instead of space rocks. So I'm originally from the East Coast, but I've been in the Bay Area for about 8.5 years now, I guess. And I went to Stanford for my bachelor's and master's degrees, and then moved down to Santa Cruz to start my PhD. And then about 2 years ago, I actually moved up to San Francisco and have been working semi-remotely since then. So I've kind of seen the wide range of the Bay Area living scenarios, I guess. When I think about climate, I think about how much I love living in San Francisco and how much I love the Bay Area. Access to hiking and biking and running and surfing and skiing, sometimes all on the same day. Even swimming, I really love swimming out in the bay as a member of the Dolphin Club. So I don't know if there are any dolphins out there. But I can confirm, based on our swim from Marina Green back to Aquatic Park yesterday, that it's getting warmer out there, but it's still really cold. Still really cold, yeah. So I'm a graduate student. I'm an observational astronomer, San Francisco resident. But another aspect of my personal identity that I think kind of informs my perspective on this panel is that I'm also part Native Hawaiian. And my late grandfather grew up on the North Shore of Maui. He was the oldest of 8 children, but only one of 3 to survive infancy. So he experienced a lot of adversity and came through all that to earn a college degree and eventually a doctorate in education. And so I think my relationship with my grandpa kind of has given me a little bit of reverence or a nuanced perspective, I guess, in how I see Hawaii and the land and the people and the ocean. And as an observational astronomer who uses the telescopes on Mauna Kea all the time for science, it's kind of also forced me to kind of interrogate that duality a little bit more. So hopefully I think we'll talk a little bit about that on the panel today. But I think I'm interested in the ethics of climate change because it's maybe a similar discussion to the one that I've been having internally for the past 4 years. And more broadly, thinking about JWST and the prospects for searching for life on other planets, how do we think about the ethics of that conversation so we don't make the same mistakes we did on Earth when we were, exploring and colonizing. So, that's my spiel, but happy to be here.
Thanks, Joey. Alauna.
Sorry. I think that my fellow panelists are pretty amazing. So it's probably not fair that I'm the one going last, but I am Alauna Wheeler. I am a physics PhD candidate at UC Merced. I do research on the fundamental physics behind the self-assembly of both biological and non-biological microstructures. And so that is like ranges from things in the medical field, like lung surfactant and how things can affect that structure, and how the COVID membrane. But my thesis work is on how we can cause nanoparticles to self-assemble into various microstructures with different morphologies, and trying to figure out that because I use a particular type of nanoparticle, but it could be done with all sorts of others. And I hope from my project to be able to use that to apply that to the medical field for like creating bioartificial organs, creating like a scaffolding for cells for that that self-assembles, and then also to apply that to like solar cell technologies and use nanoparticles, try to figure out how I can cause them to self-assemble into things that would help improve solar cell efficiency. And that's not really my area of expertise, but the reason that I attended UC Merced or applied to UC Merced is I saw that they were advertising that they did solar research in their physics department. And so I nudged my husband and I said, we're applying there, because he started with me at the same time. And actually that's what he does. So he's doing solar research and for materials for solar panels, and then also testing them for like real world usage. So I really like technologies for like clean energy technologies, and so I'm not like an expert, but because I talk to him all the time and he is an expert, I have some knowledge about that and about like what his group is doing and other groups that he interacts with. I know about especially like the solar cell and the solar thermal technologies and how they're trying to be implemented to help with with climate change and water storage and solve a lot of problems just using the energy from the sun. And the main reason I'm on this panel right now is actually I started in my second year of my PhD program. I had a little girl. I gave birth to a daughter, and just 3.5 months ago, I gave birth to a son, and he is so cute. They are so cute together, and it means so much to me that I want the world to be livable for them, right? And if climate change continues, it will not be. And I just do not want to see that world where they cannot thrive. And so the latest IPCC report came out, and we have the tools that we need to start solving the problem, to start stopping the climate change, and to start reversing it. And I think that we can continue innovating, but that is something that we can start doing. And some of it is going to be inconvenient, but I think that everybody in this world, there is no one who is more important than another person. And so there are some things that are inconvenient, but it is like we have a moral obligation to make the world a better place, to make it livable for future generations and the other people living on this planet who are most affected by the climate change, because they're not causing it, but they're affected. And so that's why I'm here.
Very powerful. And yeah, 2 parents in graduate school with 2 kids. Just think about that. Yeah, rather not. Yeah, you'd rather not. Rochelle, let's think about that. All the people in the world, population has come up a couple of times, both in an individual sense and more of a macro sense. And one of the big questions is, how are we going to feed 9-10 billion people? And a lot of debate about whether industrial agriculture can do that and scale, or if another model can feed the world. As someone who thinks about food, what are your thoughts?
Just to clarify, just on how to feed the world. So, yeah, okay.
I mean, do you think that lab meat is the answer?
Yeah,
that,
okay.
Can we engineer our way out of this?
Or, so I can talk about something that is, it's become a lot more controversial, is genetically modified food. And there are a lot of pros and a lot of cons to genetically modified food, as you might have heard a lot of general controversy about it. But I do think that genetically modified food is one way that we can feed the world. And even with the risks that it might come with, being able to produce more food that could be by genetically modifying crops to be drought resistant, or genetically modifying them to have more nutrients. So maybe you can feed someone 1 of something that gives them all the nutrients for a day instead of having to eat 5 of something. So that's one way I think is a really interesting and important sphere. And I think all the pros of that, personally, I think are far outweigh the cons. So that's kind of one way. When it comes to lab-grown meat, I think that that's a really interesting sphere for helping the environment, and I think that's a really good outlet for that. I think that it is going to be really hard to make lab-grown meat scalable so that we can feed a lot of people with it. So I don't necessarily think of that as a feeding the world kind of thing. That's more of people who can afford it can try switching out this normal meat for lab-grown meat to try and help the environment. But I think we're going to need to aim our efforts at crops and feeding more people with more fruits and plants and vegetables when it comes to feeding the world.
And also, a lot of that lab meat, we don't know what the life cycle carbon analysis of that stuff is. Even with plant-based, Impossible Burger, et cetera, it's not clear that your plant-based, which is highly industrialized and processed, is really better and has a lower carbon footprint than a real steak or beef, a hamburger from a cow. And the same for lab meat. We don't really know that it's better. Remember that Uber and Lyft started, they were going to reduce congestion and reduce car ownership. We know they have increased congestion and increased pollution and vehicle miles traveled. So Uber and Lyft did not deliver on the promise of what they were gonna deliver for us. There may be other benefits. Lainey, let's talk with you. Mentioned population, but also I want to get to biomimicry. Is the idea that that there's a reverence for nature, or is the natural world something to be dominated or something to learn from? Because it seems like engineering and a lot of work here can be about manipulating and dominating nature rather than revering it and understanding it.
Great question. So for a little bit of context, I also don't study biomimicry. But I did my bachelor's degree at the University of Akron, which is in Ohio, which is where I'm from, and they have a biomimicry institute. So I can only really communicate about the impression that I got from that program when I was there. But I definitely feel like in my heart of hearts, they are scientists and engineers that are trying to work with the planet, not against it. I think as an engineer, I feel like there's always going to be that sort of curiosity and like pushing the limits to see how good we can make something. And I can see how that might be interpreted as manipulating a situation. But for biomimicry specifically, I really feel like that the objective is to learn from the Earth and to positively impact the Earth.
Joey, you've referenced your Hawaiian heritage, and certainly in the climate world, Mauna Loa is a very important place where the Keeling curve, that's the jiggly line you saw in Al Gore's movie, that's where the carbon concentrations have been measured back to the 50s. There's also Mauna Kea nearby, that's on indigenous land. There's been quite a controversy there that kind of evokes relationship to the land. So tell us about that and how it relates.
Yeah, you may have heard of Mauna Kea. So Mauna Kea is on the Big Island of Hawaii. It's pretty much the best ground-based observing site in the world. It's essentially, go to Colorado, everybody's talking about 14ers, hiking a 14er. It's a 14er in the middle of the ocean. And because it's a shield volcano, the atmosphere just flows right over the top of it in a very laminar way. So as astronomers, when stars twinkle, it's because there's turbulence in the atmosphere. That's bad for us. We don't want the star to be twinkling. So that's why Mauna Kea is a really good place for astronomy. But anyway, yes, Mauna Kea is, I think, kind of illustrative of this problem, but issue that the field of observational astronomy has been dealing with, for decades, but maybe it's been given a little bit more serious thought to and consideration, and that's responsible land stewardship. So these observatories that we're building are oftentimes on indigenous lands. In the context of Hawaii, ever since 1893, when the Kingdom of Hawaii was overthrown. There's some people that still believe that it's occupied, colonized land. When we get to the ethics of climate change or the ethics of pursuing science, do the means really justify the ends? When, in order to learn something about the universe, we have to destroy this, dynamite this part of Mauna Kea to build a new telescope. So, recently TMT, the 30-meter telescope, has been the kind of a flashpoint of debate.
I drove by there recently. There was people camped out. There's real tension between sort of the science as seen as a talk about decolonizing science. Right. This is a really tangible example of that. Right.
And I think so this 30-meter telescope, if you haven't heard about it, is this exactly what it says it is. Astronomers aren't very good at naming things, but it's a telescope with a 30-meter diameter mirror. So it's just insane, like huge, right? Essentially, you want to go up to Mauna Kea, dynamite a huge section of the summit, and then put this giant megastructure up there. It's going to be a telescope of that size would be amazing for astronomy. It'd be amazing it would revolutionize the field of exoplanet astronomy. Everybody's trying to look for an Earth-like planet around a sun-like star that's not too hot, not too cold. searching for life. But in the process, you're kind of you're perpetuating this colonial narrative that has been going on in Hawaii for over a century, right? This I kind of see it, get it from both sides, I guess. As an astronomer at UC Santa Cruz, the UC and Caltech have been have invested a lot of resources in telescopes on Mauna Kea. That's directly benefited me because I use them all the time. Sometimes, I'm just awake from 9 p.m. till 4 in the morning at my desk in the living room because I'm controlling the telescopes on Mauna Kea with my computer. These issues really, I guess what I'm trying to say is there seems to be a disconnect from the scientists and researchers, professors that I've talked to about this issue. Sometimes it's hard for scientists to understand how somebody else could not want this brand new shiny telescope, right? Or this brand new shiny whatever it is, right? And I think there just has to be some radical empathy there in that meeting point, and some acknowledgement that indigenous people have been living on this land for thousands of years, and they know a thing or two about the stars as well, right? And thinking that Western influence research or whatever, we don't necessarily have all the answers. We're not here to save these indigenous peoples from their ignorance or something. But having a two-way conversation, having some empathy there. They're real people that are being affected by this, right? They're camping out on the access roads. So,
Alauna, you are among a large number of people who believe in creation care and caring for creation. Your thoughts about reconciling science and also responding to what Joey's saying about how some things are valued over others, where indigenous people see a whole system, right? Not just something that's anthropocentric. So creation care. Talk about your spiritual beliefs and how that brings a moral responsibility and how that relates to you as a scientist.
Okay. So I am a member of the Church of Jesus Christ of Latter-day Saints, and I have been that my whole life, and so as such, I believe in a creation of God, but I also believe in a stewardship that He's, we've been given a stewardship to care for this planet and to care for each other on this planet. And unfortunately, I've seen, what I have experienced is other people who are not religious seem to already accept that it's their responsibility and moral responsibility to care for others on the planet and to fix the issue of climate change. And it makes me very sad when I hear people justify religion as a reason to not do that, to not fix it. And I hope that none of you have had that experience, because I have talked to friends and who just say, well, what's the big deal? It'll be fixed by God anyway, and or
deny the problem. There's a large evangelical community that denies that it's a problem.
Or deny that it's a problem, and that makes me really sad, because I feel like we would have even more of a responsibility to care for the other people who are being affected, or to take care of this stewardship. And who says that God's going to fix the problem without us helping? So that's something that I feel very strongly about trying to help others see that it's everyone's moral responsibility to help each other to fix this problem for the future of the planet. And it's like, exoplanets, that's great. We want to colonize Mars, but like, if we can't take care of this planet, what right do we have to go to another one?
Thank you. Yeah, it's a big question, bigger than this. Even social and philosophical question. Let's have some of your questions. We heard about hope, coral action, etc. But let's get you here.
I would just love to know what you have done to educate the people. What have you done? I hear the problem, but you're sort of unique because if I understand it correctly, most in that religion think like what you're talking about. So you're sort of an anomaly. So, what have you done? I'm just curious, what has worked? How's it working for you?
No, that's great. That's actually what my sister said to me when I was talking to her earlier today. She was like, well, you are kind of an anomaly. And she thinks the same way I do, but I just one-on-one conversations is all I've been able to have. And I, as difficult as it has been to be in graduate school with 2 kids, and being pregnant twice and not being able to get a lot done, like I just, I feel like it's, like I have a responsibility to my community and to others, to keep going, even though it's hard, and to be able to like share my knowledge, and while holding on to my faith and my belief, and then sharing that with with my friends, like my friends at church who maybe don't see it the same way I do, but one-on-one conversations.
And that's what the research says, that trusted messengers in relationship over time, leading with listening, one-on-one in church, shouting on social media, trying to persuade people over one beer, one conversation, it ain't going to work.
My question is very directed to Joey. Last year we had a great seminar on the James Webb, and my question to you is, how has your research changed by the James Webb?
Right. So I, just as a reminder, I work in exoplanet detection and characterization, and I think the biggest boon that JWST will give exoplanets is are these observations of exoplanet atmospheres. And in order to do that, you need to precisely, before you can observe the atmosphere of this planet, or actually just interpret the observation, you need to precisely characterize things like the planet's surface gravity. And in order to do that, you have to detect and then take many follow-up observations from the ground. So JWST is opening this door to take these atmospheric observations, but for smaller planets than we've really ever been able to do before. Previously, in the literature, you've seen these atmospheric observations, but for very large, very hot planets. We call them hot Jupiters because imagine Jupiter, but you put it in a 2-day orbit around its star. So it is blazing hot. And because these planets are very big and very close to their star, the way we take this observation, the planet blocks a lot of light. And that amount of light being blocked is proportional to like the signal to noise ratio you can get on these observations. So we've been able to observe a lot of like crazy atmospheric chemistry going on in these big giant planets, but we haven't had the detailed observations and the sensitivity that JWST will give us to make these observations for much smaller planets. So those include Earth-sized planets around much cooler stars, but also sub-Neptunes are there's planets larger than Earth, smaller than Neptune, sub-Neptunes. They are the most abundant planets in the Milky Way. The Kepler space mission taught us that. But there are none in our solar system. So it's a big outstanding question, how do these planets form? And one way to get at that is by taking observations of their atmospheres, what molecules are in their atmospheres. And JWST is going to help us do that, especially with, and sorry I'm rambling on, but especially with such a successful, flawless commissioning of the telescope. the fuel, it'll be a fuel limited mission, so it'll last for 20 years or so. So if we can take, it's hundreds, almost 1,000 of these types of observations.
Next question. Yes.
Hi. I understand climate, but I don't know what you're referring to when you say sustainability. Are you saying sustainability of economic growth around the world? Are you saying sustainability of having enough water and agriculture? What is sustainability as far as you 3 or 4 are concerned?
We'd like to, that was for all 4 of you. Lainey, you want to go first?
Sure, yeah. I think that's a very legitimate on-the-nose question. I know for me personally, my first inclination is kind of like the sustainability of our water systems. Like fossil fuels, those will eventually run out. So what are ways that we can create alternatives that are more sustainable? Types of fuels, for example, that are renewable or that come from a source that doesn't have as great of a carbon footprint. But I also think that that sustainability from an economic standpoint is, I'm glad you asked this question because it's definitely something I'm going to be thinking about and is definitely a part of the solution. You have to figure out what's going to work financially as well. So that's a great question.
Rochelle?
Yeah, I agree with a lot of what Lainey said. I think, obviously, I'm, again, coming from a food perspective, so I think of sustainability in terms of, like I was talking about earlier, can we feed everyone, and can we do it in a way that is a continuous process? It's not something where we're just going to keep running out and having to find another way to dig deeper and do worse things to the environment. And so, an example of this is, I think as a society, we're starting to realize we need to start feeding people more whole foods instead of feeding them to, we feed a lot of whole foods to, cattle and animals that we raise to be eaten, but a lot of these things that we feed to them could go to humans directly and would be a much more sustainable food to give more people. So that's kind of how I think of sustainability when it comes to food. It's just being able to feed people in a continuous way that can go on for a very long time.
Joey?
Yeah, I think about sustainability. The first thing that comes to mind for me is housing sustainability, especially in the Bay Area. As the population only seems to be going up. So how do we build a sustainable San Francisco in terms of housing? I think, Greg, you had an episode on Climate One about this a little while ago. Sustainable housing kind of begets better climate outcomes, I think, as well. So what are, the political or just procedural things that we need to change, maybe starting small in San Francisco and moving out, in terms of housing to create a more sustainable city in the Bay Area?
I would have to say that I'm a physicist because I can't pick one thing. And so sometimes that's helpful. When I think of sustainability, I think of every single system that in this world being sustainable, being microbiomes, water flows, energy consumption, production of waste products, and healthy and I don't know, healthy and pleasant, enjoyable living for all the people in the world. And I would think that the climate and the world and food production and all of that, when that can all be harnessed in a way that everybody has what they need and that they receive, they can enjoy their life. To me, that's the sustainability that we are searching for, and that that takes innovation, but it takes implementation of our innovations and in every single field. There's not just one solution to climate change, but in every single field has solutions that need to be implemented in order to reach that kind of sustainability for the whole planet and everybody on it.
It's one of those meta words that depends a lot where you are and how you use it, contextualizing. Next question. I'd like. Sure.
It's so easy to think in human terms, but I'm thinking about sort of Mother Nature and all the other creatures that are on this earth. And sustainability, I think, involves thinking of their welfare also. Do you all have some ideas about that, sort of sustaining other creatures and the ecosystem?
We are in a sixth great extinction. The amount of extinction that's happening right now of other species is gut-wrenching. And some people think that but people don't realize the extent to which the economy is dependent on pollinators and all sorts of things. Where our food comes from. They think of the environment as something that's separate from us over there, and the economy needs the environment. The environment doesn't really need the economy. And so I think people are not fully aware how dependent we are, where our food comes from, and how that's being disrupted, and how species are migrating north, how species are going extinct, how we're becoming, because we're building into wildland urban interfaces, we're becoming in contact animals with humans, which gets zoonotic diseases, which get you potentially things like COVID-19. So we, and certainly indigenous people would say that we're part of this system. We're not dominating this system. Maybe some people might say creation care, be fruitful and multiply, bountiful, dominion over, et cetera. But certainly indigenous cultures would tell us that we're part of this system. We're not separate from it, and we ignore it at our peril. That's my answer. I don't know if anyone else. Sure.
Very, very similar. I would say that we can only thrive when we make sure that the other animals and all the other creatures are thriving. I mean, I don't know about spiders, but but they have their place and they are required, and so as the other, as the humpback whales are thriving, we then are thriving, and what is good for them is good for us. And so as if we're taking care of them, we're taking care of us. And if we really take care of ourselves, we will be taking care of them. That's how I see it.
There's a paper here about dengue fever, and that, mosquitoes are vectors. I looked one time at the map of Zika virus, which we think of Florida, but the northernmost boundary on the projected range for Zika virus touches the Bay Area. Think about that, dengue and Zika virus, and this is because of warming. We know this, and think about anyways, we want to keep on hope. I could bum you out with all sorts of risks coming our way. But we're not going to do that. We're going to keep it upbeat while recognizing the reality of where we are. Other questions? Let me wrap up by asking you about the role of a scientist in society. You're both individuals, emerging professionals, experts. There's a person, Rose Abramoff, who was a scientist who hung up a banner at an American Geophysical Union conference, out of the lab into the streets. She was kicked out of that conference, and she was fired from her job at Oak Ridge National Lab, which raises the question about each of you. As you think about, you care about climate and science. How do you see yourself as a scientist, an emerging, young emerging scientist, and your personal and moral commitment to acting on climate, and the trade-off between those? Lainey, let's start with you.
Okay, I don't know if I have this eloquently worked out in my head yet, so it might be a little bit of a stream of consciousness. But there's a book I read a couple of years ago called The Righteous Mind, and it's about at its core message is that you cannot convince people with data. You need to convince people with emotions, which is something that came up earlier in our discussion. So, as a
That's a tough thing to say to a bunch of scientists. The data doesn't
for sure. And it's definitely something that I have had to personally reckon with. So the way I kind of think about it is, as a scientist, I'm interested in seeing the data. And the data help me feel more confident in communicating with non-scientist folks about subjects like this. So I have the data if they're interested, but I'm just able to see them as another human being, understand where they're coming from a little bit, and just be able to connect in a very human, more emotional way rather than a purely data-driven way. So in that sense, I am hopeful that if I'm ever in a position in my future where I need to advocate for something to my employer or something like that, I would have the tools to be able to do that in a way that's productive. But yeah.
Right. Emotions are more likely to persuade people than facts or figures. Yeah. Michelle?
Yeah, I have a very similar stance, especially when I deal with nutrition. Diet and what we eat is a very extremely personal thing. So I think in my science, it's not only important to, deliver the data that I find in my research, but it's also important to deliver in a way that's accessible to people. Will people be able to afford this? Will they be able to find this? Will they be able to actually carry out these things in their real life and make an impact? So yeah, I agree. I think as scientists, it's not only our role to discover new things, but it's also our role to be able to communicate them well, and in a way that is practical for people to actually implement.
Joey, some scientists have stepped out and become activists. James Hansen has done that. Michael Mann is often, you just look at scientists on Twitter, and some people say, well, you're jeopardizing your scientific credibility. You're speaking on policy. You're not a policy expert. And you talked about a scientific facility that's at the center of a protest. Do you ever think about protesting yourself or kind of that role as a scientist?
As a graduate student, I have protested over the course of my career, and the direct action.
Santa Cruz, after all, yeah.
Yeah, and proved I got paid more. So I think direct action. It's impossible to disentangle. I think these two responsibilities that we have, not only to furthering broader scientific knowledge, but also honoring the virtues that you think are worth fighting for. It is what I'm doing. Honoring my grandpa, honoring my ancestors. Will it honor my descendants? If you have the means, I think it's also if you have the privilege to be able to take direct action without fear of retaliation, fear of maybe losing your job. I'm very thankful. Santa Cruz, I have a very supportive department, a very, very supportive advisor, secure funding. I don't feel, vulnerable, I guess, to speak my mind on some of these topics. And I think if you have that privilege or, that position of power, that you should exercise it as best you can for the people that might not be in a similar situation. So,
Alauna, would your faith compel you to at some point, I can't do this job, I got to take this risk, because you feel that overriding moral obligation?
Yes. Yes. And I think that, as a scientist, it's hard because it's the facts, and we deal with the facts. And a lot of us are introverts and shy, and but something that is maybe we have to do. Our role is to inform the policymakers, and because we're not experts in policy, but we are experts in what we are experts in, and then informing the policymakers is something that is our responsibility, and I think finding out how to do that, and then also encouraging other people, because so many things. There are things that we can do individually, but it won't make the largest difference as when the government can put something into place and the people are supporting the government putting those things into place, because we write to our politicians, we elect politicians who care about these issues, and then we write to them about what we care about, and then we hold them accountable, and we ask them to hold the industries accountable, the industries that are most responsible for this climate change, holding them accountable. And we can't necessarily do that individually, and scientists can't do that individually, but we as a society can put pressure on, our officials in order to do that collectively. And so informing them and doing that, I think, is part of our responsibility as scientists, and communicating that to people.
The most important thing you can do as an individual is stop being an individual, because that is kind of part of it is an oil industry campaign to kind of put that back on us, personal carbon footprint, which deflects the issue. And also, we can only do this together. And so if we think of atoms and what I do doesn't matter, of course it doesn't matter. The best thing we can do is together is to solve this, to come together. And it's encouraging that at Mauna Loa there actually is a new governance structure that's bringing together the indigenous people and the University of Hawaii to govern that and solve that in a new way. So they're actually merging kind of the existing power structure with indigenous cultures to come up with a new governance way forward for that facility, to find if there's a middle ground. Any last questions for our fabulous star panelists here before we wrap this up? Let's give them a huge round of applause for Alauna, Joey, Rochelle, and Lainey. Thank you very much.
Okay, we're going to do a quick wrap up. I'm Katie Hope, and this is Ellie Bingham. We are the co-presidents of ARCS Northern California, and we just want to say a big thank you to Barbara Glynn and Adriana Pope-Sullivan, who organized this evening's event, and their incredible committee for the many, many hours that they put in to organize tonight. And today is also Barbara's birthday, so if you see her on your way out, you can wish her happy birthday.
And thank you, Greg, and this whole panel. This truly has been a night where the scholars were the stars. It was so fantastic to see so many wonderful moments out there. Huge round of applause for our scholars. And I really hope all of you take this program home. You'll get a little bit of a bio from the scholars, as well as see some of our very generous corporate sponsors, our membership, all the people that really supported us tonight. And if you feel so compelled, there's also a QR code on the back. We're getting real fancy here. But I just wanted to thank you all for being here, and also our university representatives that made the journey near and far. So thank you so much. And a reminder to the scholars, you get to take those great posters home with you tonight. And wonderful to see so many people talking about science. So thanks again. Have a wonderful evening.